Now we're going to be working on a Nerf gun simulation. Last week, we played around with Nerf guns and collected a bunch of data. And this week, we're going to use that data to help us build a simulation and figure out some new things about the gun. So this is the basic simulation. There's a couple features here that may be useful. The first is I have drawn on the simulation a coordinate grid. So you can see exactly where everything is. Currently, the units for the simulation are in meters. So in the top left corner, we'll have 0, 0 meters. As you go to the right, the x-coordinate increases in meters. And because this is a Khan Academy project, the y-coordinates go from the top downwards. So it doesn't start at the bottom and go up, it goes the other way. To turn that on and off, you can press the G button, and that will just give you an extra view here. If you notice, I can also, the coordinates also follow my mouse around, so I can get the coordinates of any particular point. You can press M to turn that on and off, M for mouse. So what we have here is a Nerf gun. If you see over here, it says the Nerf gun is, I'm going to turn this off. The Nerf gun is at a 30-degree angle. It is 4.8 meters above the ground, and it's got a dart loaded in. So if we press F for firing, you'll see, boom, there goes the dart. It covered a distance of 14.15 meters before stopping. We can press R to reload, and we can fire it again, but if we want to change the angle of the gun, we can press the up or down arrows. So let's do it at a 45-degree angle and fire it again. Boom. There we go. Went a little further. We're about the same at this point. So it'll also log the time covered, the speed, that was the muzzle velocity of the dart, and K is the spring constant that of this particular spring inside the Nerf gun. You can play around, reload, fire it again, play around with the angle, see what you can get. And then you can always restart the program to bring it back to the beginning. So this is what it looks like in the end. And knowing this, once we have the simulation, we can enter in the data that we got from our lab and figure out things like the actual K constant of the spring in our Nerf guns and how much force the spring exerts on the dart. We can predict how far, once we know the K constant, we can then predict how far a new test firing is going to go. So what we're going to do is we're going to build a part of this simulation that you see here right now. First, we go to the sample project. There we go. This is going to be on Google Classroom for you. This is the same version of that simulation, but with some of the pieces set up for you guys to implement yourself. So now if we press fire, the dart does not do anything. See, the time keeps ticking up and nothing happens. That's because you need to build it yourself. So this is all the code for the simulation. A lot of it has to do with displaying how the dart and the gun work, and the graph and all these keys. If you look at the very top, we'll go to the top here, there's a couple things that might be useful. Some of this stuff just makes sure that Khan Academy uses degrees. This sets the frame rate, or how many ticks per second happen. This is if you want to slow down the simulation. You can change this time dilation. You can make it go slower or faster. Restart that. You're not going to see very much, but now we sped it up by 2. We could change it to 0.5 to slow the whole thing down. This would change the, again, these are the variables that control like the angle of the gun, but you can just modify it with your keys. How high the gun is off the ground. Whoops. Restart that. There you go. How high the gun is. Whoop. You got to restart once you do that to get it to display correctly. Boom. Change that to, let's say, 5, or 7, or 6. There we go. Now notice the muzzle of the gun is a bit higher up. So you really need to do is kind of play around with this. You can press the plus or minus keys to change the height of the gun, more fine-grained, and that way you can get the actual height that the dart's going to fire from. We start off with whatever the spring constant is. If we change that, there we go. It's going to change up there.